Hello, so welcome to this episode. And this episode of AI LLM MCP security is on supply chain and dependencies. So now it's MCP04 is tagged by OWASP as chain and dependency tampering. So here I want to just make some characterization before we move forward. Now, what MCP04 actually is about trust in component your MCP server is built from or distributed through. Now, the core vulnerability statement I want to make here is every component in your MCP server supply chain, let's say SDK, plugins, dependencies, connectors, and distribution channel itself runs inside your trusted execution path with the full permission of the surrounding code. Any one of them can be compromised without your knowledge. Now, how does this happen? Three distinct attack surfaces sit under this statement. Let's look at one, dependency tampering. A package your MCP server depends on is malicious, compromised, or silently updated to become a malicious one. Now, what do you do to tackle this? You make sure you handle floating versions, pin it. Okay. Now, the second attack surface is network exposure of development servers. A development or debugging tool for MCP servers is exposed beyond its intended boundary, allowing an attacker to reach it from outside. So what do? You bound your development server to IP address of 127.0.0.1 instead of 0000. Okay. Now, the third attack surface is distribution channel compromised. Now, when your MCP server itself, not just its dependencies, but its distribution is untrusted or compromised. How does this happen? Now, community built MCP servers publish on NPM on PyPI with no provenance verification, or legitimate MCP server taking over and a malicious update pushed, no SBOM, no signing. Now, what do you do to fix that? Is sign the component with provenance and SBOM. Then the other one, which is like another attack surface, I said it was 3, but let me add this, is plugin and connector injection. A third-party plugin or connector that extends your MCP server introduces malicious behavior. How do you fix that, or how does that happen? Plugin execute in the same process as the MCP server with full permission, no sandboxing. A compromised plugin reach everything the server can reach. Now, how do you fix that? Sandbox third-party plugins. Now, so these are the statements I want to make about MCP04. Yes. Now, MCP04 is all about supply chain and dependencies and how do you manage them in a secure manner. So moving forward, if you look at my slide, you will see that the MCP inspector remote code execution with CV SS 9.4 from Anthropic's own official dev tools that has like 38,000 weekly download, was a victim of this. That is your network boundary. Then the postmark BCC, the raw pool pattern was also a victim, or was, let me say, a kind of a use case for what I call a floating of components. Now, moving forward, I want to just say some things here, and so that before we move forward to our hands-on environment. Okay, when you install a package, you are not adding a feature. You are extending full trust to whoever wrote it, maintain it, and could later compromise it. And there is no such thing as low privilege dependency. They all run with the keys. This is not a new attack class. SolarWinds in 2020, Code Cove in 2021, XC, until in 2024. Supply chain attack have disrupted the organization for years. The amplifier is new. Now an autonomous agent is within the compromised dependency at matching speed across everything that agent can reach, with no human pausing to notice something is wrong. Same attack, new engine attached. Now, the two attack surface we are focusing on out of the 4 I mentioned earlier today are specific and concrete. Network binding. I've mentioned that you don't bind your development environment to the loopback address like 0.0.0.0.0. Instead, you bind it to 127.0.0.1. This is a one character configuration difference that determine whether your development server is reachable from outside your machine. Then the second one is version pinning. The latest versus a specific version number. So this is the difference between upgrade automatically to whatever shift next. And I know exactly what code I am running. 2 decisions, 2 CVs, 2 fixes you can implement before this, even before this video ends. So that is what I want to bring to us in our lab or project session. So what I want to achieve, like I said, is to help you understand how you protect your development environment from being protect your development environment from being taken over or compromised from outside world. And the other thing is to make sure that you regulate how your upgrade and how the component you use in your MCP server, how you protect them from being compromised or hijacked, from when you are moving from one version to the other, or maybe when the components are upgraded. So yes, so let's move to the hands-on. So now the first thing I want to walk us through in this lab is what I call, bounding your development server to look back address. Not, the loopback address like 127.0.0.1, not allowing it to communicate over the placeholder address, which is 0.0.0.0. That is open to the devices on the internet and even external, to external network and even your own local network. So it's kind of a very unsecured practice. So the first thing I want to do here is to create so let me do this. So let me create this server. So when I do this, okay. So now if you look at it, it says it's listening on this interface because I directed it to listing on that interface. Okay. So let me do, okay. So now let me prove it's reachable. So let me prove that this is reachable. So how, let me see how, let's just look into some of my commands. So now I am calling it from using a call command, using the IP address, the loopback address. So it says the server name is MCP server. Dev server is no authentication. The tools are file read, file write, execute, no authentication required. So let me call it from the placeholder address and see what we got. You see, so I called it from the loopback address, show me everything from the other address, which is external, that is open to the external world, which is placeholder address. It also show me that. So that is to tell you that this is the risk. This shouldn't be open. This particular server should not be bind to this address, but it does now. Okay. So now what do I do? Check what the server is actually listening on. So let me do this and let's see what is coming up here. You see, it's listening on this port. This process and this port number. So yeah. So if you look at 000 there, means that every network interface, including one exposed to your local network. So how do we do that? Let me key this server first, and then from there we'll see a fix. So I've given to you how you can configure, assemble your MCP server and allow it to be listening, to be able to receive connection from external world, not from your local environment alone. So that is what that does. Okay. So now if that works that way, then let's look at the second attack surface. I'll come back to this, is floating version pins. So let's do that. So let me bring this to this. Okay, it's there. So now if you look at my package JSON file here that I'm creating here, one thing the name of this server is vulnerable MCP and the version is this. Now if you look at the dependencies I'm using here, SDK, I kind of tag it to latest. The server GitHub is .asterisk, that shows anything can come in. That's white card there. Express is this also is more or less like a white card. You can see the way all of them are floating. They are not pinned to specific versions. Apart from Lodash is pinned to this version 4.17.21. So let me run this. I have that, and then the next thing I want to do is to scan for floating version pins. So let me scan for it. I have a script that will do that here. Okay. So this is my script, and you will appreciate that when I execute that script. Now, okay, let's look at what we got here. Okay, see. Now, this is the output. This is where I want you to pay attention. So, floating version pins found. Critical. The SDK to latest. It says that critical auto upgrade to whatever attacker pushes next. That shows that with this, if an attacker gets hold of this particular SDK and push something next, maybe something that is malicious or compromised, then whatever it is, your MCP server will pick it up. Now, the other one is this. if the GitHub critical, you can see the asterisk here, which is wildcard, auto upgrade to whatever attacker pushes next is still the same thing. You see this particular yes, see it here, allows minor version changes that you might not take that serious. Then this medium allows patch version changes. So all these things, they are breeding ground for attack surfaces or attack surface. So it's very important that you take care of this some way within your MCP security workflow. So you can see that. So what do I see here is the fact that you have been able to, if you are able to get this done, know that, okay, this is a problem, then you can find a way to fix it. So the first thing I want us to fix is the one of the server, the one that is bound to floating interface. So how do we take care of that? Let me create a safe a safe server here. So look at my safe server. What I'm saying is that it should be bound only to loopback address, not a placeholder. So when I run this and say, okay, so let me call it again. You can see server name is MCP dev server. Binding is localhost alone. That is 127.0.0.1. Okay. And let me try to verify where it's listening on. Okay. So you can see it's listening on that IP address. Okay. So 127.0.0.1 only local loopback interface. DNS rebinding cannot reach this. So that is to tell you that what you need to do when you have your development server, MCP server, is to ensure that you bind your communication, channel to the right address, not something that is exposed to the whole wide world. So the second, fix here is to pin the dependency. So this goes to the second attack surface. That is how you manage your dependencies, how you manage your dependencies, how it comes in and goes out. So let's do this. I will create the fix file package. So it's kind of very simple. I think I've explained that already. So if you look at my file, what I'm saying here is that very simple. When I'm creating my package.json file, I pin it to specific versions. SDK 1.0.4, GitHub server 2. Server GitHub is 2.1.0, Express 4. Specific versions pinned down, for that. So at the end of the day, if that is happening, I can say, okay, let me do something to verify. Let me write a script to verify that script is written. Then let me run the script. I think I have a scan. The scan already. Okay. So if you look at my check, all 5 dependencies pinned to exact versions. So you don't leave it floating, but you pin it to exact version so that it will be very difficult for an attacker to take advantage of that floating values and do something that will not be recognized, weaponize those versions to use our own advantage. So this is how that is fixed. Then the other thing you can do is to install something we call Sift. So now what does this do? Maybe I should do that. It's just to help you to generate bill of material. So let me just try and do that here. Okay. Let me see if that goes well. Okay. So Sift allows you to generate bill of materials for your dependencies. So let me do so dev scan. Then I can come here and see. Okay, cool. So I can come here and do this. 1 sec. I'm almost there. Okay. Then now I can generate my bill of material. Okay. So I'm in dev scan. Okay. So you can see the SBOM generated. You can see components, 5 components. You can see all of them and the versions that they hold at the moment. So with that, I have been able to show us what we can do, to kind of secure against 2 of the 4 attack surfaces that you can come across in MCP 04, which is supply chain and dependencies, tampering. And with that, I want to say this before I leave. So it's just like a summary statement that bind to loopback address, DNS, rebinding cannot reach the server. Stop the MCP inspector, RC class, everything that fall under that particular attack surface. Just stop it by doing that simple thing to make sure that our development servers are bound to the right IP address or address. Then the other thing is to pin all dependencies versions. Ensure that you don't allow auto upgrade. Cannot just happen without your approval. A typical case of postmark rug pull class. Then the third thing is that generate SBOM, just to help you have visibility and answer some questions. So this is what this particular MCP we allow you to, we help you to achieve. And thank you once again for this particular episode. So the last episode on this series, which is AI, LLM, MCP, server, let me say EMC server security, is the last one, which is on MCP 08 and the MCP 10. So what that takes, so it's all about detection, isolation, and response. But for now, this is the end of this. See you on the next one.